morning, good afternoon, good evening. We are back and we are better than ever. How could you possibly be downhearted, baby? As we are continuing our journey through calculus. Today, we are talking about derivatives of exponential functions. Specifically, we're going to focus on the most important exponential function of all, and that is f of x equals e to the x. But before we do that, let's just do a quick little review of our exponential functions. Maybe the most basic one is 2 to the x, this green function. Remember, all exponential functions have this basic shape. As the base gets larger, the graph becomes steeper and goes to 0 more quickly. As the base becomes lesser, then it becomes less steep. And then when you get between 0 and 1, then we flip over the y-axis and the shapes go like this. So just really a quick review there. They all pass through the point 0, 1 because anything to the 0 power is equal to 1, and they do not cross the x-axis. They don't go below it if they're of the form b to the x. Okay. And there's our good friend e to the x. So we are going to explore, of course, if we have f of x equal to e to the x, then what is the derivative of e to the x equal to? What's that equal to? Well, I'm not going to show you the formal proof, but I am going to give you a visual proof. Okay? Remember that the derivative is the slope of the tangent to the curve. So I have graphed e to the x here, and I have done a tangent, or I've drawn a tangent line at a particular point. Remember, the slope is a value. The value of, or the slope of this line is right now 1.81, which also means the slope of this curve at this point is 1.81. And just so you know, I'm not messing with it, you can see that as the tangent line gets steeper, the slope increases, and as the tangent line gets less steep, the slope decreases. Okay, so how does this help me? Well, I have now highlighted the coordinates, the x-coordinate and the y-coordinate. Now remember, the y-coordinate, since it's on the this point is on the curve, the y-coordinate gives the value of the function for this given x-coordinate. So I'm going to drag it and stop every once in a while and see if you notice anything. Hopefully you're seeing something. Okay, hint, hint, take a look at the slope of the tangent line and the value of the function. Okay, 3.98, 3.98, 5.37, 5.37. Okay, 0.92, or I'm sorry, 2.51, 2.51. So what does this mean? This means when x equals 0.922, the slope of the tangent line, the slope of the tangent to the curve is 2.51, which also is the value of the function for 0.922. Okay, there we go. 1.5 at x equals to 1.55. The value of e to the x is 4.72, and the slope of e to the x at 1.55 is 4.72. So this is a visual proof that the derivative of e to the x is itself. It is e to the x. If f of x equals e to the x, the derivative of f of x is e to the x. And I'll go back to this picture again just so you can see the value of the function is the same as the slope, no matter where I put it. If I drag it here, okay, 0.105, 0.105. A bit of a formal proof, I just put it on there, appears here. We had talked about the number e and how we came across it. The limit as n goes to infinity of 1 plus 1 over n to the n. We did that back in chapter 3. But for right now, there's a formal proof that I can show you in class. But for right now, we are going to accept as true that the derivative of e to the x is e to the x itself. What could be easier than that? This comes directly from your formula sheet. Sometimes, rarely, instead of e to the x, it's written expx. I think that takes place in a couple of the homework exercises. Now, what if we have the function e, but it's something to other than x? Of course, e to the x is a function, but they're just saying, okay, what if it's something other than x, like negative x or 2x plus 3 or negative x cubed? Well, what happens is we have a chain rule situation here. E to the f of x equals, in the u substitution here, chain rule says dy dx equals dy du times du dx. Derivative of what we had learned before is a little bit of a shortcut. Derivative outside times derivative of the inside. But for e to the f of x, the derivative of e to the f of x, or e to the f of x, is equal to e to the f of x, again, it's itself, multiplied by the derivative of this function here. So for example, the derivative of this e to the negative x squared would be, okay, so let's just say, ooh, what happened there? Let's say f equals e to the negative x squared. So f prime would be equal to e to the whatever, e to the negative x squared, times the derivative of negative x squared, which would be negative 2x. I guess this is redundant. The parentheses would have been enough. Okay? And we could simplify that, but that's just a quick example. So let's do some examples here. Find the gradient function for y equal to, so this is all y equal to all of these functions. So for a, okay, y prime is going to be equal to, this is just a coefficient, so it comes along for the ride. The derivative of e to the x is e to the x. So that's very simple, very easy. 2e to the x plus, okay, so now I have a function, I have something in the exponent that's not just plain old x, so I have to use this rule right here, which is not on your formula sheet. So that's equal to e to the f of x, whatever it is, so it's e to the negative 3x multiplied by the derivative of this function, and the derivative of negative 3x is negative 3. So you clean this up a little bit, so that would be 2e to the x. I'm going to put the minus 3 out front, minus 3e to the negative 3x, and you are done, 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 done. Okay, let's do b. So y equals x squared e to the negative x. This is product rule. So product rule says y equals v du plus u dv. Okay, so my u is x squared, du is 2x, my v is e to the negative x, and dv is equal to, again, I have something other than x here, so it's equal to e to the negative x multiplied by the derivative of negative x, which is negative 1, so it's equal to negative e to the negative x. So now I'm just going to use the product rule. Oops, this is y prime, sorry. Y prime is equal to v du. So v is e to the negative x multiplied by the derivative of u, so that's times 2x, okay, plus u is x squared, dv, what's dv? Negative e to the negative x. So if we clean it up just a little bit, we finally get 2x e to the negative x. This is going to be minus, let's see, e to the negative x. Well, no, we have our squareds first there, so I'm just putting this minus out front. So minus x squared e to the negative x. Okay, and then finally c, e to the 2x over e to the x. Now, if I don't have to use the quotient rule, I'm not going to. So I'm going to rewrite this as e to the 2x times x to the negative 1. The product rule is easier than the quotient rule. So again, using the product rule, I know that, let's see, this is my u, just so I don't have to rewrite everything again, and this is my v. So u prime is going to be equal to e to the 2x times 2, which is equal to 2e to the 2x. And let's see, v prime I'll put over here. V prime is going to be equal to x to the negative 1 is going to be negative x to the negative 2. So that means that y prime equals v du, so that's x to the negative 1, times du, which is, let's see, 2e to the 2x, okay, plus u dv. So what's u? U is e to the 2x times dv right here, so that's times negative x to the negative 2. And I'm going to clean up that up a little bit. I mean, this is a perfectly good answer, but I'm going to clean it up, get rid of negative exponents, and just make everything nice. So this would be 2e to the 2x over x. Okay, and then this minus would come out front, so minus e to the 2x over x squared. Okay, final examples right here, wrapping it up. Okay, so y is equal to e to the x minus 1 cubed. Okay, we have a function within a function, so we're going to have to use the chain rule. Y prime would be 3 times e to the x minus 1 squared, derivative of the outside, multiplied by the derivative of the inside, and the derivative of e to the x minus 1 would be, well, the derivative of e to the x is e to the x, and the derivative of negative 1 is 0. And we clean this up just a little bit and rewrite it as 3e to the x times e to the x minus 1 squared. Last example. And let's see, I'm going to rewrite this one as y equals 2e to the negative x plus 1 to the negative 1/2 power. So we're going chain rule. Y prime equals, chain rule, let's see, negative 1/2, derivative of the outside, 2e to the negative x plus 1. Minus 1, so this would be minus 3/2. So I've taken the derivative of the outside. I'm going to multiply that by the derivative of the inside. And so that's going to be, the coefficient stays 2. We have something other than f of x, so e to the derivative of e to the negative x is going to be e to the negative x times the derivative of e to the negative x, which is negative 1. Okay, so it's all one big happy multiplication family, and if I clean this up, a negative times a negative is a positive, so I'm done with those guys. And let's see, what's going to remain in the numerator? 2. Yeah, this 2. And then everything else is down low, man. So this 2 right here is down low. Ooh, we're going to get some cancellation. This comes down to e to the negative x plus 1. And then the 2e to the negative x comes down as well. 2e to the negative x. Kapow. Hoop-de-doo. So there's a 1 up here. So my final answer would be 1 over 2e to the negative x multiplied by 2e. Oops, look, I forgot to put the 3/2 here. Ooh, what a loser I am. So 2e to the negative x plus 1 to the 3/2. Now I just cleaned it up. Understand, this is a perfectly good answer, but if you had to evaluate, this would be a better form. That is all I have. I am out!